Hello everyone, this is Zavier from and today we are going to talk about the first basics on project for high school students that is called Reenactment. Today we are going to discuss about work, energy, and power. And before we continue to further discussion, there are two questions which I need to personally answer, which are why do visionary leaders adapt and how can human analyze transformation based on physics concepts and law in a day-to-day life activities? Okay. By the end of this project, students are expected to be able to develop a forward-thinking design based on the understanding of Newton's law of motion, able to understand, able to analyze a daily life problem based on the principle of work, energy, and power. So why is this topic important? Okay, you may think that this topic is not important, but think about it. Even the smallest thing can make a big change. And remember that Newton found the law of gravity only by observing an apple that was fallen from the tree. So don't underestimate little things. Alright, so let's analyze this image. First, you need to list down all information because it can help you in many ways. And is it possible an object that can be calculated using physics if it doesn't violate the law of physics is possible to be analyzed? Because after my research, this object has velocity or acceleration and mass, so it is possible to be analyzed. How about the environment? Environment may influence the other informations. However, we don't need to consider environment as a factor here due to its limited influence. So after we know all the informations, we need to develop the hypothesis. If I am able to estimate the mass and acceleration of the cable car, I can analyze the force needed. I may also discover the kinetic energy and potential energy and the mechanical energy that can be created from this photo. Let's continue. So now that forces, kinetic energy, and potential energy can be analyzed in this picture. And before we go further, there are some definitions that you need to know. The first one is normal force. The keyword is always go with your direction. So let's say this picture, this person moving to the right direction, so the normal force will also move to the right direction. And the second one is friction force, resistance of normal force. So actually the friction force is the one that always resists to the direction of normal force. So the friction force will go to the left side. And next there is tension force. This force can be transmitted from rope, chain, etc. And there's no tension force in this image, but I'll explain it to you later. And this one is weight. Always relates with gravitational force. So it is always move down here. Now let's continue. And next, there is energies. There are three energies that can be analyzed. Uh, there are three examples of energies that can be analyzed in this image. The first one is kinetic energy. The keyword is velocity because it's related with velocity. And the opposite is potential energy, which is related with heat. And last, there is mechanical energy. It is actually the difference between potential energy and kinetic energy. Now we analyze the force. Now we assume that the direction is moving to the right side. This is just a normal assumption. And be careful on what you count because they are counting the distance that the cable car is moving. We are calculating the distance from the cable car to the ground here, not from the cable car to the base, which is really far away. Alright, let's continue. Because the direction is moving here, the normal force will follow the direction, and the friction force will resist to the direction. And the tension is exists between the cable car and the one that moving in. And weight, because it is related to the gravity, always moves to the earth, the center of the earth. So before we continue, we need to understand that this object implements the Newton's first law of force that says an object remains at rest unless there is a force back to it. Now we're calculating the energies. All right, so before I continue, I just want to explain that all informations here I got from research. So basically, if you want to calculate something, make sure you do some research before you make your own assumption. Now let's continue. The formula of kinetic energy is 1 over 2 times the mass that I found from research is 2,800 times velocity square, which is 62. And now we calculate the kinetic energy. Actually, this is 6 uh, to the power of 2. Sorry for my mistake. The kinetic energy is 50,400. Now, the potential energy. The potential energy, the formula is actually mass times the gravitational force, which can be 9.8 or 10 times the height, which is 60 meters. This is I found from research also. And we get the potential energy is 1,680,000. Now, answer to the big question, when do fictional leaders adapt? Fictional leaders adapt by calculating or creating the new concept made by physics based on their current condition or problem occurred. And answer to the next question, human can analyze information based on physics concept by looking at the detail about things that currently being analyzed. Research can also help in some problems. So make sure you do some research first. Now, benefits of using physics in daily life. Can understand the materials that can be used to make things, and through calculations we could solve problems which could not be answered in the past, and investigations. Physics help us investigate things in the universe such as gravitational mysteries and others. All right, so the mechanical energy. I just wanted to talk about the mechanical energy. The kinetic energy and potential energy I got here is actually at their own maximum points. The mechanical energy, on the other hand, so let's continue. For the mechanical energy in the lowest, it will be uh, the same with the kinetic energy. For the highest point, it will be the same with potential energy because it assumed that it hasn't moved in the potential in the highest point. So I think uh, for the other height, we can simply subtract the potential energy with the kinetic energy. So that's it for today, and thank you for listening, and see you next time.